Okay, everybody, so this video will be a combination of a few topics. On one hand, it's about one-sided limits. On the other hand, it's about limits that involve infinity also, okay? But it's also I don't know, I could call it a word problem. I don't really like that term, but this problem is about something. Something's happening. There's measurements that are being made. And then we're trying to do a little bit of analysis on top of that, all right? So I want to do this question about if we were going to start in one place and travel to another place at some average speed, and then return back to where we started at some other average speed, okay? So that's the basic scenario. And this is the question ultimately that I want to do for you. But let's start with something that's, I think, a little bit of a warm-up to that one. It's not hard for me to just tell you how to do that one, but I feel like I could explain it a little more than just work it, okay? So here's the scenario I want you to think about. We're traveling between two cities, and we leave and go from city 1 to city 2 at an average of 20 miles per hour, okay? And then we return at some average speed of y miles per hour, okay? And the cities happen to be 40 miles apart. All right, so there's my scenario. Now, I'm just curious what your instinct tells you about this. If I say that the average speed for the entire trip is 39 miles an hour, how long was the return journey? And what was the average speed on the return journey? Okay? All right, so somebody might say, okay, well, this is what you want here. The average speed when we leave is 20 miles an hour. And the average speed when we return is y miles an hour. So we average those numbers and we get 39, right? So what does this average speed need to be? Okay, so in any case, if we do a little multiplying, then we'll get like this. And then if we subtract, we'll get 58 miles per hour. All right, I do all that just to tell you, well, that's not what we mean when we say the average speed for the journey, okay? What we mean by average speed is the distance you travel over the time it takes you to travel that distance. We're not saying average the numbers, okay? So I'll say that to clarify that's not what we mean. This is not what we mean when we say something like the average speed for the entire trip, okay? All right, so that's the first thing to establish about that. So anyway, so let's see, well, how would we work it then? If it's not like that, if we're not saying that you just average the actual numbers together, then what do we mean by that? Okay, so I'll show you in this question what we mean. But what do you think the answer is? How fast would this have to be for the average of those, so to speak, to be 39? How much faster do you think that would need to be? You would think this average speed would need to be faster than that one if the average for the entire trip is 39 miles an hour. But how much faster? I just kind of want to pose that question and see what your instinct tells you about it. All right? I'd say, maybe it's like 60 miles an hour or something like that. Who knows? But let's go ahead and work it. We'll find out. All right? So let's do this. We'll say that when you travel, there's a certain amount of distance covered. There's a certain time it takes you. So let's say that it takes me time t1 to travel from city 1 to city 2, and time t2, some different time, to travel from city 2 back to city 1. So let's just suppose that that's the way it works. Okay? Then I can find out what t1 is. Right? So what we mean when we say average speed is the total distance over the total time. Okay, so I'm going to write distance over time, but it's the total. So on this leaving journey right here, the distance is 40 miles. And we're going to suppose it takes us time t1 to do that. Okay? And the average speed that we get is 20 miles an hour. So this is enough information for me to solve for T1, how long it took me to get from city 1 to city 2. Okay, so if I multiply and divide here, I'll get that T1 is equal to 2 hours. Okay, all right. So how can we, with that, figure out how long the return journey was? Okay, if the average speed for the entire trip was 39 miles an hour. Well, okay, so for the entire trip, okay, the average speed is 39 miles an hour. But that is, any average speed anywhere is the total distance over the total time. So if the average speed for the entire trip is 39 miles an hour, well, that would be 80 miles of distance, right? 40 and 40, supposing the cities are 40 miles apart. Okay, and then over the total time. Well, okay, so the total time, we just figured out it took us 2 hours to get from city 1 to city 2. The return trip from city 2 back to 1 times T2, we don't know. That's what we're looking for. So here's your equation to figure out how long in time the return journey was. We know the average speed for the return journey. We know that that's the total distance over the total time. The only element of this equation is we don't know the time for the return journey, okay? So if we do a little multiplying, we can get 2 plus T2 is equal to 80 over 39, okay? And then we can solve for T2, the length of time on the return journey, by just subtracting. So T2 is equal to 80 over 39 minus 2. So let's figure out what that number is. 80 over 39 minus 2, not very big. Turns out to be about 0.513, roughly. 0.0513 hours. That's not very long at all. Okay? Now, how does that translate into the average speed? Okay, what was the average speed on the return journey? Well, again, what do we mean by average speed? It is the total distance over the total time. Oh, on the return journey, it's 40 miles. Okay. And then the total time, that's what we figured out here. Okay, well, that's going to be very fast. So I'll take 40 and I'll divide by that number that I just got. 40 miles, it only took you 0.0513 hours. That turns out to be exactly 780 miles per hour. Now, I just thought that might surprise you, how fast that return journey has to be just for the average speed for the entire trip to be 39 miles an hour. I mean, you went 20 miles an hour on average when you left and went from 1 to 2. I mean, did you expect a number in the magnitude of the 700s to have to be the average speed on the return journey just so the average speed for the entire journey was 39? So I thought that might surprise you, so I wanted to show you that just because I think that the result is counterintuitive, but I don't think we can argue with the math, all right? Given that the average speed has a pretty simple definition. For any trip, for any length of trip when you travel, it's just the total distance over the total time, okay? So, all right, I'll put an exclamation point because I think we're going to be surprised about that. All right, so that's how that one works. I wanted to point that out to you. And I remember I asked you to make a guess. I said, about how fast do you think your average is going to have to be on the return journey for the whole trip to average out at 39 miles an hour? Well, I don't know. Was your guess anywhere near that? Maybe it was. Maybe you've got a really good instinct for math. I would think for most people it probably wasn't anywhere near that, though. Okay? All right. So that's just a little bit of an introduction to this problem that is my real objective. Okay? So this is the one that I'd like to work start to finish in more detail. You probably see one like this, the one that's more like this on the assignment. but it seems similar in its origin, that we're traveling between two places. We go from our starting point to our ending point at an average speed of X miles per hour, and then we return on an average speed of Y miles per hour, and so on, okay? All right, it says this. Let's say, first question. If the average speed for the round trip, for the entire trip, the whole distance back and forth was 50 miles per hour, can you derive a function y is a function of x? So first of all, what do we mean by that function? It's a formula where x is the input, meaning your average speed on the leaving journey going from start to end. And then if I tell you that number, you can calculate y, the average speed on the return trip. That's what that formula is going to do. That's what we mean when we say y is a function of x. Okay? All right, so let's figure out a way to do that. Now, I told you my definition already, or it's not just my definition, it's the definition for what average speed is. It's going to be the total distance over the total time. Okay? All right, so I say 50, meaning that was the average speed for the round trip, is the total distance over the total time. Okay? All right. Now, what's the distance? Well, the distance wasn't given. All right? But how about this? Let's say that these two places are d miles apart. Because it wasn't given, but that's obviously something that's relevant. So I don't know what it is, but I need to give it a name. So I'll say d. So the total distance was 2d. All right? Okay, and the total time. Well, okay, so I need to somehow figure out how long did it take to get from the starting point to the ending point, and how long did it take to get from the ending point back to the starting point? I got to figure that out somehow. Okay? So we could do something like this. Say that on the leaving trip from start to end, that the time is t1, but that's how long it takes you to get from here to here. And to get from here back to the beginning, let's say the time for that's t2. Okay? How could I get the distance? Well, isn't it true that, if that's the average speed, right? That's total distance over total time. Okay? So that's the relevance of this number. When you tell me that the average speed from here to there was X miles per hour, then you mean I went the distance d, given that the cities are d miles apart, over the time it took me, t1. I don't know what that is. But that's what I want down here. Okay? I want t1 plus t2. So, okay, I've got a way to give you that number. t1 is d over x. I'm trying to get x and y into this, right? I'm trying to take that number and get some formula that involves the average speeds in each direction. So look, this says if you solve it, t1 equals d over x. All right, so I get 2d, and t1 is d over x. In the same manner, t2 is going to be d over y. All right, so that's better. That's more of what we're looking for here, okay? Now, I'm trying to get a formula that involves the variables y and x with this specific arrangement that when you plug in the x, you get the y, okay? So I'm headed in the right direction. Let's recopy this. Okay, so I get 2d d over x plus d over y. That's the operative equation that I have at this point. Now, I notice I can factor out the d and cancel it. So I wasn't given the distance between the cities, but that's okay because it factors out. So look at it like that. Factor out the d here, d times 2 is 2d. Factor out the d here. If I were to multiply d times 1 over x plus 1 over y, I would get d over x plus d over y. and then it cancels. Okay, so I'm getting a little bit closer. 50 is 2 over 1 over x plus 1 over y. All right, so at least now I have a formula that only involves the variables y and x. Okay? All right, so now could I arrange it so that you plug in the x and you calculate the y? Okay, so what I'll do for that is this. Let's add these fractions together. Suppose we got a common denominator of x times y. We would get y plus x over x times y. And then, given that I want 2 and I'm going to divide by this fraction, that will be 2 times x times y over y plus x. Okay? So I'm going to reduce to this. All right. Now, okay, so I'm almost there. I'm getting closer. Next thing I'll do is I'll divide both sides by 2 so that I don't have redundant numbers of 2. 50 is 25 times 2. So that's going to give me 25 x times y, y plus x. Now I'm trying to figure out, can I solve this for y? Can I get it in terms of y being a function of x? So I'll multiply both sides like that. I'll distribute. I'll remove all terms that have y to one side, say the left-hand side over here. Terms that have only x and not y, I'll move over here. I'll factor out the y and I'll divide and I'll have what I want. Okay, so see there I've isolated the y, finally. It took some rearrangement. And it took the right conception of the starting point too, all right? But anyway, so I get this. Here will be my answer. Negative 25x over 25 minus x. So that's good enough. It would be fine to leave it like that. I think one more thing I want to do is multiply the top and bottom by negative 1. It's because that negative seems a little redundant. And that'll give me 25x over x minus 25. Okay, so that's the one last thing I'll do to that. But I'll just go ahead and I'll write that as my answer over here. Okay, so can you get some function? Y is a function of x. Yes, so that's what we just figured out. Y is equal to 25x over x minus 25. All right, there. So what does this function do? You plug in the x, which is the average speed in this direction, and it will calculate y, what the average speed on the return journey needs to be. What assumption is built into that? That the average speed for the entire trip was 50 miles an hour. So if the entire trip has an average speed of 50 miles an hour, and you tell me what the average is in the green direction, this will calculate y, the average in the return direction. Okay? All right, so what's the domain of this? Well, when I look at this originally, I would say the only number not suitable as an input for this function is 25. So I'd be inclined to say negative infinity to 25 union 25 infinity. You know, for this function, just as it is, that's what I would say the domain is. But this x and y has a measurable meaning this time. They're not just variables. So I have to take into account that means something. And let's say, what's wrong with numbers in this interval? Like say, what's a number here from negative infinity to 25? The brackets are excluding, or the parentheses are excluding the 25. This says all numbers but 25. So say I took 24 over here, and I put it in this formula, and I say, suppose that the average speed in the green direction was 24 miles per hour. What would the average speed on the return direction need to be for the whole trip to have an average of 50? Well, if I put 24 here, I get 24 minus 25. That's a negative number. It calculates y to be some negative number. So apparently that's not possible, all right? It is not possible to have an average speed in this direction of 24 miles per hour and maintain an average for the entire trip of 50. It just can't happen. So this is what I'm inclined to say the domain is, but then I realized that numbers in this interval are meaningless, and the domain is just 25 to infinity. Another way to say this, if you don't like the interval notation, is just that x has to be greater than 25. Not greater than or equal to, just greater. Okay, so I got my function. Now I've got the domain, and I realize there is a restriction to that. The least that x can be to maintain this average for the round trip of 50 is some number that's just a tad bigger than 25, okay? All right, now, so calculate this limit. What happens to y, let's say, as x goes to 25 from the right, okay? Now, I've got my function at this point, so I'm gonna rewrite this. Limit x goes to 25 from the right. There's my function. 25x over x minus 25. Okay? So what happens to the, I guess you could say, average speed on the return trip as the average speed in the green direction approaches 25 from above? So if like you were at 25.5 and then 25.4 and then 25.3, what would this do to keep the average for the round trip to 50? That's what this is asking us, okay? Now, here you might be surprised about the answer, but I showed you this, remember this first one? And I said, well, if we average 20 miles an hour in the green direction, and the average for the round trip is 39 miles an hour, how fast do you think the average needs to be in the red direction? And it turned out it was a lot bigger than somebody may have expected. You'd have to go 780 miles per hour on the red direction right here to maintain that measly average of 39 miles an hour for the round trip. Okay, so that number was probably bigger than we expected it to be. But anyway, what happens here? Well, so we talked in other videos about limits and infinity. And the way I'll analyze this one is, well, if x goes to 25 from the right, this number down here approaches 0, okay? And this number up here will steady at 25 times 25. Okay, so I'm going to say this. We get a positive number over this, a very small positive number. So the smaller number you divide by, the smaller and closer to 0 your number is, the bigger your answer is going to be. That's just how arithmetic works. So as soon as we see that this bottom part is going to 0 and this top part isn't, as x goes to 25 on the right, we know the answer is infinity or negative infinity, okay? But the nature of this one is that will be some positive number, and this will be what? What is 25.01 minus 25? It's a very small positive number. So that's suggesting our limit's infinity, okay? So can you imagine that? The closer our average speed in the green direction gets to 25 from above, the faster and faster we have to have an average for in the red direction to infinity, right? So I was like, no limit to it. Think of how close you can get to 25. That just means that this average is going to shoot up further and further and further, faster and faster, which might probably be surprising before we look at the details. You may not have expected that before we looked at it. Okay, but it's just like that on this one, you may not have expected a number that big.